Hey, AP Chemistry. Another question that some of people were asking about was question number 111 from Chapter 1 Exercises. So this is a good exercise for college. You're not going to have to do too much of this in AP Chemistry, but it's good to know for math and how to rearrange units. So it says force is defined as mass times acceleration. Starting with SI base units, derive a unit for force. Using SI prefixes suggests a convenient unit for the force resulting from a collision with a 10-ton trailer truck and and a 10 to the minus 20th kilogram. Let's start with the first one. Derive a unit for force. Force is mass times acceleration. So force is equal to mass times acceleration. Now, I conveniently put up here what acceleration is. You could find this online. It might be in the chapter, or you could find this in other textbooks. But acceleration is speed divided by time. And speed, which is v, or velocity, is distance over time. So the units for velocity would be meters per second. And then the units for time would be per second. Or second, sorry. The units for time would be second. Meters per second over second ends up being meters over second times second, which is meters over second squared. Otherwise, you could look up online that the units for acceleration are meters per second squared. Okay, so the units for acceleration are meters per second squared. Do you have to know how to do that? Not really. I'll just tell you that right now. For SI units for mass, it's kilogram. So we have kilograms times meters per second squared. This is equal to force. Another unit for force is known as the Newton. So a Newton in SI units is kilograms times meters per second squared. Okay? So now it says using this derived unit, come up with a unit for a force resulting from a collision with a 10-ton trailer truck moving at 55 miles per hour. And you could use SI prefixes. So 10 tons and 55 miles per hour, we could convert that. And I'm going to do that quickly on the top here. I wrote down that 1 ton is 907.2 kilograms. So 10 tons times, if I'm doing dimensional analysis, ton goes on the bottom. Kilogram is what I want. Why do I want kilograms? Because that's our SI unit for mass. So 907.2 kilograms goes on top. 1 ton on the bottom. I get 9,072 kilograms. And for miles per hour, I want to convert that to meters per second. Okay? And so if I want to... Oh, is that the... Yeah, if I want to convert that to meters per second, okay, now this one's a little bit tougher. If I want to do 55 miles per hour, I have miles on top and hour on the bottom. So I start with miles on top, and I'll put miles on the bottom. And I want to convert that to meters. And I wrote here that 1 mile is 1.6093 kilometers, which is the same thing as saying 1.6093 times 10 to the third meters. So 1.6093 times 10 to the third meters is 1 mile. Okay. If I do this math, I'll do 55 times 1.6093 times 10 raised to the third. That converts the miles portion of this into meters, and I still have the hours. So far this is 88511.5 meters per hour. And then if I want to convert the hours, hours is on the bottom. Remember with dimensional analysis, we want to cancel out units. If I have hours on the bottom, I'm going to have to put hours on top. And I want to convert this to seconds. I put seconds on the bottom. 1 hour, I wrote up here, is 3,600 seconds. So I could do 88511.5 times 1 divided by 3,600. So I'll divide this by 3,600, and I'll get 24.59. So I'll do 24.6 meters per second. Okay? So I have a mass of 99,702 kilograms, and I have a speed of 24.6 meters per second. Okay, and I'm gonna write that down there. Now it says come up with a convenient unit for this. So if I want to do force, let's say I was doing it in 1 second. I know my time is 1 second. I'm making that up. Force is equal to mass times acceleration, and acceleration is speed over time. So let's say this was a time of 1 second. It's going to accelerate for 1 second. Force is equal to 9072 kilogram times 24.6 meters per second over 1 second. I'm just going to assume 1 seconds, and I'm going to get a really big number, 9072 times 24.6, and then I'll divide that by 1. I get 223171.2. Okay? Let me turn this into 2.23 times 10 to the 5th. We know all of this is a Newton. If I want to, just like in question number 56, I can convert this into a larger number. I could say that this is going to be like, if I move this to the decimal point over to the left 1, this can be 0.223 times 10 to the 6th Newton, and 10 to the 6th could be 0.223 mega Newton, mn. 10 to the 6 is mega. Okay, now this is a lot of work, especially for AP Chemistry. I was just showing you how you can convert between units. I'm not going to ask you to do something like this in AP Chemistry, but it's just good to know how you can move units. So I'm going to say skip the small part for now, but if you're interested in understanding the small part, you could do force is equal to mass, which is 10 to the minus 20th kilogram, times 3 times 10 to the 8th meters per second. And let's say you're dividing by 1 second. You're going to get 3 times 10 to the minus 12th Newton, because kilograms times meters per second squared, meters per second over per second, is going to be 10 to the minus 12th Newton, which you could also say is, if you look up in your textbook, I believe that's a Yocto Newton. So if you go to page 17 in your textbook, I'm going to do that on the side here. If you go to page 17... 10 to the minus 12th, if I'm looking up on the side here, 10 to the minus 12th is a pico Newton. So I could say 10 to the minus 12th, this is 3 pico Newtons. Or the way they express it is a little p, so 3 pn. So that's what they mean by expressing a convenient unit with SI units. So you could check your answers with all of this. This is a bit long. I would focus on understanding maybe how I get units for force. Mass is kilograms, acceleration, like I told you, is meters per second squared, and I'm just combining those two. Alrighty, so hopefully this was an in-depth explanation for question number 111. Again, this is a bit outside the range of AP Chemistry. I would just know how to do scientific notation and converting between units.